Hello everyone, welcome to another video of mine. I decided that I'm gonna shoot this video outside because it is a beautiful weather and it would be a shame to miss it. And as soon as I said that, the wind started picking up and filming was just unplayable, so I had to come back to the office and I'm gonna finish the video here. As you might have guessed by the title, I am going to talk about Le Chatelier's principle. Why? Well, because it is one of the most fundamental things in chemistry and it is important for you to understand it before I dive into more complicated matter. And I am going to try to give my best explanation and I'll try to break it down as simply as possible. I find this to be particularly important because most reactions in nature and in real life form an equilibrium or a balance. Very few go all the way to the end, meaning there are no more reactants, only products. If we look at the definition, Le Chatelier's principle states that if a dynamic equilibrium is disturbed by changing the conditions, the position of equilibrium shifts to counteract the change to re-establish an equilibrium. This definition I have found on chemlibretexts.org, and on Wikipedia it states, when any system at equilibrium for a long period of time is subjected to change in concentration, temperature and volume, the system changes to a new equilibrium and this change partly counteracts the applied change. These are very vague and very general definitions, and to some people it might be confusing. And I will try to break down what happens when change in concentration, when a change in temperature and a change in pressure is applied to the system, and how it translates to the change in equilibrium. To explain all of this on an example, I am going to be using the reaction of nitrogen and hydrogen to create ammonia, because it is a very easy example to explain everything. And I am going to start by explaining the concentration because I believe it is the easiest to understand. In the beginning of the reaction, when you look at the container, it only contains hydrogen and nitrogen molecules. And they start reacting between each other and they form ammonia. And they keep reacting until they reach the state of equilibrium, or when they balance each out. Meaning now you have hydrogen, nitrogen and ammonia molecules, and for example, if 3 molecules of ammonia are made, then 3 molecules of ammonia are disintegrated into hydrogen and nitrogen, and that's what we call the state of equilibrium. And if we were to extract the product, in this example ammonia, then the reactants would continue to react between each other to create more ammonia. And that's an example of change in concentration. If we remove the product from the container, then products react between each other more to create more product. The same happens if, for example, there is more of hydrogen, for example, then there is more hydrogen to react with and they give more product. Long story short, if you take the product out of the container, then the reactants give more product. If there are more products, then it moves the balance back. If there are more reactants, then they give more product. And yeah, I'm gonna stop there. As an analogy, when a baker has flour and eggs, he makes bread. and bread stays at the shelves, he sells the bread. Now he hasn't got any more, so he has to make more. Makes sense, right? This method of using more reactants to give more product is actually a very common thing in the pharmaceutical industry to get more product. Also, the extraction of a product is another method used to increase the yield of the reaction. Next up is temperature. And temperature is also easy to understand. If you increase the temperature of the system, it actually favors the endothermic reaction, because the endothermic reaction uses up the excess of heat added to the system. If you drop the temperature of the system, it favors the exothermic reaction because it will bring the heat back up. And in our example, it is a very exothermic reaction, so an increase in temperature actually favors the reverse process. It favors the forming of reactants, not the product. Wait, that reaction you are talking about, the reaction of getting ammonia, I've heard that in the industry it is being performed at 400 degrees Celsius. I mean, did you make a mistake or something? You are right, and it is as efficient because of pressure. An increase in pressure favors the reaction that creates fewer molecules. In our example, in the beginning, we have 1 molecule of nitrogen and 3 molecules of hydrogen. As a product, we get 2 molecules of ammonia, 4 in the beginning and 2 at the end. That's why increased pressure is the reason why the reaction itself is so efficient and widely used. On the other hand, if we were to decrease the pressure of the system, we would favor the reaction that gives more molecules. In this example, that would be the reaction that would give us hydrogen and nitrogen molecules. And it is quite simple, actually. If you increase the pressure, then it's kind of crowded for the molecules, and they favor the reaction that kind of tries to give each molecule more space. And if they have room to breathe, then of course they are gonna try and give more molecules because they don't want to feel alone. To summarize everything, I have found this picture on Pinterest, and if you check it out closely, you will see that there is a catalyst at the bottom. And I haven't talked about a catalyst because no catalyst ever can change the equilibrium. It can only get to the state of equilibrium faster. And that's actually a characteristic of every single catalyst. And just to give some further explanation so that you would not be confused. If you still have something that is not clear to you, make sure you write that in the comment section so that I can answer you. If you like the video, make sure you hit the like button, and if you want to see more videos, subscribe and share the fun with your friends, and I will see you in the next one.